Hello.
Hello.
This is this is Stephanie, and this is my husband.
John.
Thank you for being my partner for the partner project.
Thanks for asking me.
And thank you for doing the video with me as
You're
well.
welcome.
Okay. All right. Do you remember what our game is about?
It's rolling dice and picking cards.
Excellent. Okay, so we actually handed a proposal into Dr. Mears, and we got an 8 out of 8. Woo woo! There we go. Yeah, all my handwriting. You're going to be writing up that outline. So what we do is we roll 2 dice, and what happens, John?
If we roll 2 through 7, we move on to the next round. Otherwise, we are done.
And then if we move on to the next round, what do we have to do?
We have to pick a card and hope it's black. Black wins.
Black. Oh, it's red. Black. That one. We got it. 7. Excellent. Thank you. Okay, so how much does it cost to play? Do you remember?
$2.
Excellent. And how much does it cost to win? Thank you.
If we win, we get $5.
Good. So what is our profit?
5 minus 2 is $3.
You got it. Thank you. Okay, so that was all in our proposal document. Now, Dr. Mears says that we have to name our game because, as you can see, our little poster was kind of lacking. So you have to think of a good name to name our game.
So I was thinking if it was a basketball game, it would be pick and roll, but we do that backwards, so we could call it roll and pick.
All right. I like that. Hey, the Celtics won last night.
Doing a roll and pick.
I know. So I was very excited about that one. Okay. All right. Well, I'm going to take over from here so that I can show them how to do the probability model.
Great.
Okay. Thank you for your help. Okay. So here we go. So here's the outline that we're going to have to do next. And in the outline, you have to say the rules, and then you have to list your outcomes, and then you have to list your probabilities. From there, you have to create a table, a histogram, and calculate the expected value. I'm going to show you how to do number 2 and 3. Number 4 is the histogram. Hopefully you can do that. Google Sheets might even help you. And then 5, I'm going to teach you how to do expected value. Here we go. Pardon me because I do have to move my camera over, and I'm not going to be cutting the film out because this is happening right now. So moving over to the other side of the table so that we have no shadow interruption. And here we go. So we're rolling. There's my kitchen. So we're rolling 2 dice. And when we roll 2 dice, this is what happens. Turn this like we're used to here. Okay, here we go. Put the cord out of the way. Okay. So when we're rolling 2 dice, this is what happens. We have 36 possible outcomes, and I really don't like that shadow there, but we have 36 possible outcomes. We have rolling a sum, and I'm talking when the 2 dice are face up like this, 1 and 1, and we add them together, we have a sum of 2, and that's the number here, 2. So that's rolling a 1 and a 1. A 3, we can get a 1 and then a 2, 1 and a 2, or we could get a 2 and a 1. So it could be the other way around. So the order matters here on which number comes up on which dice. And when that order matters, that's when we have 36 different pairs. There we go. So if you want to take a snapshot of this, our 36 different pairs, here you go. This is how they come up. Okay. Now, what we're going to do next is we're actually going to be figuring out our outcomes, which is number 2 in your outline, and we're going to be calculating the probability of each outcome. And what I'm going to do, I think the easiest that's going to be for us is to make a tree diagram, and we're going to list the outcomes of our game. So through the tree diagram, and we're going to be doing win-lose. So here we go. The first part of our game, we can win if we roll a 2, 3, 4, 5, 6, 7. We lose if we roll an 8, 9, 10, 11, 12. And from the losing, we don't get to go on anymore, so that's it. From the winning, we get to go on, and we can win if we pull a black card, and we lose if we pull a red card. So these are my sample spaces right here, and if we win or we lose. Now what I'm going to do is assign a prize amount to each. And what I'm going to do, I'm actually going to be using profit. So remember, it's $2 to play, and it's $5 when we win. So I give 2 Mears monies to play. If I win, I don't get anything yet, so I'm not going to write anything down. I can move on. When I move on, if I win, I get $5, which means that I'm only making a profit of 3. If I lose, I'm losing my $2, so that's minus 2. So our minus means losing 2. Now if I play, I get my $2, and if I automatically lose, then I automatically lose my $2. So there's my tree diagrams with my profit, my sample space, and if I won or I lost. I'm going to go on to number 3. Well, actually, I'm going to go on to number 4, which is to create a table. So this tree diagram actually helps me to answer questions 2 and 3. Now I'm going to go on to numbers 4. So this was number 2 and number 3 together. Now I'm going to answer question 4. In question 4, I'm going to write down on this second half of the paper. This is number 4. So my table. Here I go. My outcome, my probability of that outcome, and my profit. So I'm going to turn my tree diagram into a table. So my first outcome, I'm going to go win, win. So my win-win situation is getting a 2, 3, 4, 5, 6, or 7, and rolling a black card. And notice my and I put on as a little multiplication symbol. My win-win situation gives me a profit of $3. Now let's put some probabilities in here. My win-win. So we're going to go back. That first time that I win, I have a sum of 2, 3, 4, 5, 6, or 7. Now there's 36 outcomes. So what I have to do is I have to count up all of these out of 36. That gets me when I win. And so there's 21 out of 36 that I can win. So my probability of rolling a 2, 3, 4, 5, 6, or 7 is 21 out of 36. And I have to pull a black card. Now, black, there's 26 out of 52 cards. So, and 26 out of 52. So here we have our outcome, our probability, and our profit. It also helps us to fill in our tree diagram. I would appreciate those probabilities in your tree diagram, just like we've been doing all along. Okay, my next is win, lose. And I win if I do 2, 3, 4, 5, 6, or 7. But I ultimately lose if I pull a red. And I will ultimately lose $2. Now I have a 21 out of 36 chance of pulling a 2, 3, 4, 5, 6, 7. I do also have a 26 out of 52 of pulling a red. So this again is 21 out of 36 times 26 out of 52. Or I can just lose. Just losing is 8, 9, 10, 11, or 12. Losing, if I add up all of these, so 8, 1, 2, 3, 4, adding them all up, there's 15 different ways out of 36 And if you add 21 and 15, that is 36 out of 36. Remember, these do add up to 1. So it's going to be 15 out of 36. And I ultimately lose $2. Now, I would like something else in this diagram, in this table actually. The tree diagram is perfect. Please make sure that you do put your probabilities in there. It does help you to complete your answers to number 2 and 3. But what I would also like in the table are your decimal approximations to 3 significant figures. So if you multiply this in the calculator, clear that out, and we put parentheses 21 divided by 36 times 26 divided by 52, just as you see it, and you get 0.291666666. So this would be 0.292, so I do want those 3 significant figures. So this equals 0.292, this also equals 0.292, and this equals 0.417. So those decimal approximations are going to help you do your expected values. Now, when you do your histogram, doing the probability and the profit would be great, so that I know we have my probability and how much money I'm going to be getting. You could also do the outcome and the probability. I would just show the distribution as well. Next, if you have questions on making a histogram, come and see me. You can use Google Sheets for that. That's absolutely fine. Just make sure that you check with me and you also attach it to your document correctly. Next is going to be the expected value. The expected value on your outline is going to be number 6. Expected value, and let me give you the definition of what expected value is. Let me see if I could get it a little bit clearer, because a little bit now we're into that writing that I usually do. So here we go. Expected value. Let me clear that up. So this should be expected. Little type. Expected value describes the long-run average outcome. If someone played a game of chance a very large number of times, it is the long-run average gain we would expect to receive. So that's what we're going to be doing. So it's the long-run average gain. So we don't just play this game once and this is what we expect. We have to play it many, many, many times. So, and it's what the average of what we would expect to receive, and so hopefully average reminds you of the mean. So it's sort of a long run mean. And that's what we're going to be doing for our game, is finding out what we're going to have as our long run average gain. And this is how you do it. From your table, what you're going to do is an expected value equals, you're going to take each one of these probabilities and multiply it by its profit. So I'm going to take my 0.292 and multiply it by its profit, which is 3. I'm going to add that to the next one. 0.292 weighted by its profit, -2. 0.417. Actually, it's the profit weighted by the probability. So the profit weighted by the probability times -2. I'm going to multiply and then add these up, and I get -0.54. So here's what my expected value looks like. Each profit weighted by its probability. So 0.292 times 3, 0.292 times -2, and 0.417 times -2, and I get -0.54. This is how you show me expected value in your outline. Again, you can write it out. It's absolutely fine. You can actually write out the table if you want. You can write out the tree diagram as well. That's absolutely fine. There are programs in Microsoft Word that you can also use. And lastly, what I'm going to ask you to do is I'm going to ask you to write it in context. So writing this in context. So if a person played our game of chance several times, then the mean amount a person gained would be negative 0.54. Actually, they wouldn't be gaining. They would be losing a mean amount of 54 cents over a long, long series of plays. Now, my partner actually crossed this out and wanted me to write many, many times because he said it is the long run average. So he read over my work before I submitted it and said, we have to change this to many, many, because it's not just several. And he said several makes it feel like one or two, but it's not. It's many, many, infinitely many times that a person plays. The mean amount that they would be losing would be 54 cents. So this has been our tree diagram. This has been our probability model. This has been expected value. This has been writing it in context and learning the definition. And this has been, seniors, the last video that I'm going to be making you this year. So congratulations on graduation. Good luck. This is Dr. Mears. Hope this helped.